This is problem 17 of Chapter 18 from the textbook Stats Modeling the World. I think it's the second edition. Okay, for this problem, what we have is we have trucks coming in from orchards, I suspect, with harvested apples, and they're taking them to a packing plant. And the packing plant is randomly selecting 150 apples off of each truck. So let's assume that each truck holds around, I don't know, it's probably well into the thousands, like 10,000 apples or something. And they're going to look for bruises, discolorization, defects. Basically, they're looking for bad apples, in short. Okay, so now here's something that we don't typically know, is that we kind of have historical evidence that suggests that 8% of the apples are bad. Okay? So this is based on records that are kept. So without challenging that, this would typically, we're trying to estimate this, or this is hypothesized. So here we actually see it as this is fact. Okay, so that tells us that if we were going to sample apples, we expect that the center, the proportion of bad apples would be 8%. So we would expect to get a histogram like this. However, we know that it's going to vary. Okay, so what we would like to do is build a model that tells us not just what to expect in terms of the center, but also what to expect in terms of variability. Okay, so we can use the normal model for a sampling distribution. If each dot here would represent a truck load or sample from a truckload. But we have to check the conditions first. So a random sample condition is met. Okay, we have random samples of 150 apples from each truck. And yes, you have to write this out every time. 10% rule is in effect, I believe, because let's assume this is a big truck. So 150 apples is less than all apples. I believe we should say on a truckload. Okay, and then success failure, there we have to test that. We want to know if n times p is greater than or equal to 10 and n times q is greater than or equal to 10. We have to check that. So let's see, n is 150 and p is 0.08. So maybe I should say NP equals. And so that turns out to be 12. So that's greater than or equal to 10. Okay, and so this should be easily NQ is 150 times 0.92. And that comes out to be 138. So that's greater than or equal to 10. Okay, so the conditions are met. We can use a normal model for the sampling distribution of the proportion of, and I'm just going to say bad instead of unsatisfactory, bad apples. Okay, so with So the center is going to be 0.08, 8%. So with mu, a center, equal to P of 0.08. And the standard deviation, which we have to calculate, but it's a function of P, and the sample size, P times Q divided by N, so that's going to be the square root of 0.08 times 0.92 divided by 150. And that comes out to be 0.0222. Okay, so now if I take this standard deviation and subtract or add it once, I get I'm going to put a 0 there. I get 0.102, and if I add it again, I get 0.124, and if I add it one more time, 3 standard deviations out, I get 0.147. Now if I subtract it, I'm going to get 0.058 and then 0.036 and then 0.013. Okay, so this would be what we would expect. You know, if a truck came in, we would expect the bad apples, the percent of bad apples, to range between here. Now, what do I mean by here? Well, we have the 68%. So 68% of the time we expect between, looks like 5.8% and 10.2% bad apples. And 95% of the time, we expect between 3.6% and 12.4% bad apples. And finally, and let's just say between 1.3% and 14.7% bad apples are expected let's see, 99.7% of the time. Okay, so we don't really have room, but let's see, how can I do this? Maybe down here. I did it wrong. 99.7% of the time. Okay, 3 standard deviations in both directions. Okay, so if they're asking you to build a model and asking you what to expect, then they're asking you to build a model, so that's what you do. You build a model. Now, sometimes you're not asked to build a model, but you're asked a probability question. So what you have to do is you do have to check the conditions, okay, and you have to say the conditions are met, so they are already met, so we can just go ahead and use that information here. Since the conditions are met, now they want to know what's the probability that the shipment will be accepted. Well, remember, in the information we're given, it has to be less than 5%. Okay, so they want to know what's the probability that P hat, the sample distribution is less than 0.05. That's what we're being asked. Okay, so if this is 0.08, let's just see. Okay, so this is 3%. Here's 5.86%. So it's somewhere in here. Okay, it's about 1.5. My guess is somewhere in here. I don't quite know where yet, but somewhere in here. Okay, so we want to find the area. Let's just say this is 0.05. We want to find this area. Okay, that's what they're asking us. Okay, so now what we got to do is we got to compute the z value. So this is the probability that z is less than, okay, so 0.05 is the observed value minus the mean 0.08 divided by the standard deviation, which is 0.0222. That's the standard deviation of the sampling model. Okay, so remember that z, if you forgot, is the observed value minus mu divided by sigma. Okay, so what we're doing is we're calculating this area under the curve. Alright, so this comes out to be the probability of z less than negative 1.354 is what I get. So now I can use my calculator, normal CDF, and we're going to go from negative infinity out here, negative infinity. So I'll approximate that to negative 1.354, and that comes out to be 0.088. Okay, so this is area is 0.088. The corresponding z value right here is negative 1.3354. So that makes sense that we're 1 and a little more away from the mean. So according to the normal model, the probability of having less than 5% bad apples is approximately 0.088, or maybe 8.8% of the time. Okay, so I guess of the time means of the trucks. So there you go. That's how you do this type of problem. And remember that this model that we build, the variable here is p hat. Okay, we didn't actually go out and sample 100 trucks and check and build this model. We built a theoretical model instead and used it. Okay, good luck.